Hello, everyone. My name is Olivia Turner, and I am a second-year graduate student in the Master's of Neuroscience program at McMaster University. Today, I will be presenting preliminary results for my thesis on the influence of stress on reward learning in a recreational cannabis use population. Since the legalization of recreational cannabis by the Canadian federal government in 2018, cannabis use has continued to increase, where 7.9% of Canadians over the age of 15 report using on a daily basis and 20% report using within a recent 3-month period. Stress is a commonly reported reason for using cannabis, and research has shown that individuals who use cannabis have blunted stress system reactivity. Cannabis use is implicated in reductions in motivation, where chronic or heavy use can lead to cannabis becoming the primary source of motivation, where other activities including school, work, socializing can become less rewarding over time due to reduced reward learning capacity. These changes in motivation suggest that differences in reward learning may occur over time. A previous study has shown this reduced capacity for reward learning using the same behavioral task we use in the current study in a group of individuals who use high-potency cannabis. The current study has two main objectives. The first is to evaluate the effect of stress on reward learning in individuals who use cannabis regularly, which is defined as at least 2 or more times a month, while in a non-intoxicated state using the probabilistic reward task, or PRT, which is a validated measure of reward learning. Participants were randomized to a stress condition where they underwent a stress induction paradigm or a no-stress condition. The second objective was to assess in the cannabis group for an association between cannabis use metrics, including frequency, age of onset, and reported THC potency with reward learning capacity as assessed by the PRT. In the current study, subjective stress is measured by total mood disturbance on the Profiled Mood States questionnaire. The stress induction paradigm used is the Trier social stress test, a validated measure of invoking acute stress, and the behavioral measure of reward learning is a probabilistic reward task, visually depicted here. So participants are presented with either a long or short mouth, one of which is presented at a rate 3 times greater than the other in order to induce a response bias toward the more frequently rewarded stimulus. And learning occurs over 3 blocks of 100 trials. The study consisted of 2 separate assessment days. On day 1, we collected demographic measures, mental health history, and cannabis use characteristics. Day 2 began with a baseline state measure of mood, for which we collected measures of TMD, or total mood disturbance, over 4 different time points. Following the baseline mood assessment, individuals randomized to the stress condition underwent the Trier social stress test, while those in the non-stress condition completed crossword puzzles for 20 minutes. TMD was again assessed post-stressor, followed by a behavioral task unrelated to the current study. A third mood state TMD was assessed, again followed then by the reward learning task of interest, which was the PRT, and a final assessment of TMD. Our sample began with 106 people, which was reduced to 70 after inclusion of people with PRT data that did not meet quality control checks. There were 36 in the cannabis group and 34 in the control group, each randomized into stress and no stress groups. As you can see, the stress and no stress groups are not balanced due to randomization and inclusion of participants based on the PRT data, but there was no trend for exclusion by groups or conditions. And there were no significant differences in mean age between groups, and both groups consisted of predominantly females. Average age of onset of cannabis use was around 18, as was years of use. Most use cannabis with THC potency of anywhere from 15 to 30%, or they didn't know the potency of the cannabis they were using. And average QDIT scores indicate potential problematic use, but not necessarily cannabis use disorder. We looked at TMD across 4 time points of the experimental session, pre and post stressor. The Trier social stress test occurred between time points 1 and 2, indicated here by a red line. Collapsed across stress condition and time, the cannabis group reported higher stress levels compared to the control group. The cannabis stress group in particular reported overall higher levels of TMD across the entire session. The initial heightened measure at baseline was unexpected given condition randomization, but it might be due to the small sample size. Both cannabis and control groups in the stress condition showed a significant rise in self-reported stress after the acute stressor compared to the no-stress groups, which shows that the acute stress manipulation was effective in inducing subjective negative affect within the stress groups. Both no-stress groups showed a flat TMD score over the experimental time points. However, even here, the cannabis no-stress group had higher TMD values across time. Evaluating group and condition on response bias, which is our main indication of reward learning on the PRT, we found that both groups and conditions similarly developed a response bias across blocks. That is, after the first 100 trials on the task, individuals showed a response bias for the reward paired stimuli. The cannabis group showed a less steep learning curve from blocks 1 to blocks 2, although this group difference was not statistically significant. We also assessed the secondary measure of the PRT, which was accuracy. The accuracy measure indicates if participants are able to correctly identify the more frequently rewarded stimuli over time, or the rich stimuli. The rich stimuli is the one, again, most frequently paired with the reward. The results reflect the pattern we wish to see, which is that both groups are more accurate in their identification of the rich stimulus. Therefore, we can more confidently consider the response bias results to be reliable. There were no group differences or differences between stress conditions found in regard to accuracy across blocks, which is in line with our response bias results. The interaction effects are driven by the difference in rich versus lean accuracy collapsed across groups and conditions, as discussed in the previous slide. As mentioned before, one of our objectives was to assess for associations between reward learning and cannabis use metrics. However, no correlations were significant. This includes assessing correlations between age of first cannabis use, years of cannabis use, THC content, or QDIT scores. The current study is novel in evaluating a recreational cannabis community sample on this measure of reward learning specifically with a stress induction paradigm. But neither cannabis or stress differentially affected the ability to form a response bias on this reward learning task. Our findings are in contrast to a previous study by Lon and al., who found that individuals using high potency cannabis didn't form reward associations on the PRT. However, our sample consisted of individuals who predominantly used dried flower cannabis with less than about 30% THC. Findings suggest that moderate recreational cannabis use does not appear to impair reward learning for novel stimuli. The acute stress manipulation significantly increased subjective mood, and the cannabis stress group showed significantly higher TMD than controls across all time points. Further analysis will explore this abnormal finding. This is the first study to examine reward learning in individuals who use cannabis recreationally, but do not necessarily have cannabis use disorder. Individuals not meeting quality control measures on the PRT were removed from analyses, thereby reducing the sample size, and unexpectedly, the cannabis stress group showed higher baseline TMD. Future analyses can evaluate response bias using quality control measures from the Lon et al. 2016 study, and another important direction is to quantify salivary cannabinoid metabolites to evaluate their relationship with reward learning measures on the PRT. I'd like to thank and acknowledge the Peter Bohr Center for Addictions Research and the Michael G. DeGroot Center for Medicinal Cannabis Research at McMaster University. We also acknowledge the research assistants and students for their tremendous help with the project, as well as the guidance of Diego Pizzagalli and colleagues.